So length, time, mass, volume, electric current, luminous intensity, area, these are all the fundamental quantities and derived quantities. 7 fundamental quantities are there. Another things are derived quantities. So 7 fundamental quantities. Using that fundamental quantities, we are derived the quantities. That here the 7 fundamental quantities are length, mass, time, electric current, thermodynamic, temperature, amount of substance, and finally luminous intensity, that is called candela. Okay, these are all the fundamental quantities in SI system. So already we have seen that. So on the basis of these quantities, we are going to explain the dimensional analysis. So dimensional analysis. Now we are going to see the dimensional analysis and what is the use of dimensional analysis. Basically, we are using only these 7 fundamental quantities. Using this for 7 fundamental quantities, we can give the dimension for the derived quantities. So, for example, derived quantities are volume, velocity, acceleration, and mass density. So, volume can be defined on the basis of these fundamental quantities. Velocity also we can define. So, now you can consider that a man is acting, pushing that luggage, that's a force acting on an object. So, force equal to mass into acceleration. So, force equal to mass into acceleration, where mass is the fundamental quantity, but acceleration is a derived quantity. When you are multiplying the fundamental quantity and derived quantity, you will get the derived quantity. So acceleration equal to change in velocity by time. You know that velocity equal to displacement by time, or rate of change of displacement is called velocity. So you can write that equation like this. So to find the force, displacement equal to length. Displacement is measured in the fundamental quantity of length. So 1 meter, 2 meter, like that. So velocity equal to length by time. So velocity equal to length by time. So use these quantities, we can derive the quantities of force. So acceleration equal to velocity by time. Instead of velocity, we are writing the length by time. So length by time is the velocity. Velocity by time. Rate of change of velocity is called acceleration. So substituting that in force equal to mass into length by time divided by time. So mass we can write power value is 1 because it is in the numerator. Length is also in numerator, we can put 1. But time is in the denominator, 2 quantities are there. So it has the value of -2. So denominator value value put it will get -2. So mass power 1, length power 1, time power -2. So here we are raising the power values of fundamental quantities. This is called dimension. So we are raising the power of the fundamental quantity. Mass, length, time are the fundamental quantity. We are raising the power of the fundamental quantities. So we are writing in that in the square bracket. These fundamental quantities are called dimension. Okay. So here the mass, the dimension, where mass is defined as the letter in M. Like that, the length is also defined the letter L. And time period. So mass divided the letter M, and length is defined the letter capital L. All the letters are capital. Time for T, capital T. So these are all the letters defining in the dimension form. So see that these are all the 7 fundamental quantities, and these are all the basic representation of the 7 fundamental quantities. L, M, T, I is for the electric current, and thermodynamic temperature you can write K. Amount of substance you can write, that is mole, MOL. Luminous intensity, that is candela, you can write CD. So this is the dimension for the fundamental quantities. These 4 fundamental quantities. So now you can see that how to write the fundamental quantity. Instead of mass, we can write the force. We are going to find out the dimension for force. Force or dimension la eppadi eludrom appdi paaka porom. So force eppadi eludhalam appadina, that force F is equal to, so that mass is the mass power N, L power 1, T power -2. So we can write in a single square bracket, mass, length, T power -2 is the dimension for force. So like that, we can write all the derived quantities. You can write the dimension for all the derived and the fundamental quantities. So ML T power -2 is the dimension for force. Okay, so this is a dimension formula. So this is the method of writing the dimension formula. So fundamental quantities of the power must be raised. So fundamental quantities are there. So using that, force is equal to ml t power minus 1. So the force is acting on the direction, it has the displacement, and the displacement also measuring the length. So now we are going to use only these three fundamental quantities: length, mass, and time. Okay, these three fundamental quantities are going to use for the other quantities. So in dimensional analysis, we can use only three fundamental quantities. The remaining four quantities we are not using the four quantities. Only we are using the three quantities: length, mass, and time. So L, M, and C. That things are going to used in the dimensional analysis. Okay. So this is all the basic representation of the mass. Mass is M equal to M, time equal to T, length equal to L. So now we are going to derive the equation for the pressure. Pressure equal to, you know the formula. Dimensional formula for pressure equal to force acting per unit area. That is pressure equal to force per area. Force divided by area. We know that area equal to length into breadth. So area means area equal to length into breadth. The length and breadth is measured in the quantity of length L. So instead of length, we can write L. The breadth is also measured in the form of length. So writing that length L. So area equal to length into length, because breadth and length is a length. So area equal to L square. Area equal to L square is the dimension. L square is the dimension for area. So force already we calculated that ml t power minus 2. So substituting these two values in that equation, pressure equal to force per area. So L is the power minus 2. Numerator cancel ana ml power minus 1, t power minus 2 is the dimensional formula for the pressure. Now we are going to see the dimensional formula for volume. So length, breadth, height. Sorry. Okay. So length L, breadth L, and height is also measured on the basis of length L. So volume equal to length into length into length. So we can write volume equal to L cube, where L cube is the dimensional formula for volume. So L cube is the dimensional formula for volume. So now we are going to calculate the dimensional formula for mass density. Density equal to mass by volume. So mass by volume. So density equal to mass M, volume L cube. So we can write dimension for density is M L power minus 3 is the dimensional formula for density. So by using the dimension, we can write equation for all these three quantities: force, pressure, and density. So we know the formula for force, pressure, and formula for density. We know that dimension formula for all these three quantities. Okay, like that we can do calculation for all the fundamental quantities and the derived quantities. That other unit of force is Newton. You know that pressure Pascal, and density equal to kilogram power meter cube. So this is also a unit for the force, pressure, and the density. Right? So force you can write the Newton or that formula. So relative density. So relative, here we are going to relate the two densities. So relative density equal to density of the substance divided by density of the water. So density, we are dividing that value by density, the density. So what will happen? Definitely numerator and denominator have the same value. They cancel each other. So now you can write it that density of the substance is ml power minus 3. Density of water also ml power minus 3. So they cancel each other. So this type of quantities does not have any dimensional. So here also absolute refractive index. That refractive index also does not have any dimensional formula. So idukella pathina dimension formula kedaiyadhu. So for light is passing from air to glass medium, refractive index is mu. So speed of the light in vacuum to the speed of the light in medium. So speed is here. Same formula for the speed for light and vacuum and the medium. So definitely the two formulas are cancel each other. So there is no dimensional unit for absolute refractive index. So the refractive index is indicate the letter of mu. So see here, like that only the light is transmitting. This refracted inside the glass. Okay. So these quantities does not have any dimensional formula. So these are called dimensionless constants or dimensionless derived quantities. Okay, some quantities have the dimension, some quantities do not have any constant. See that universal gravitational constant, weight constant, universal gas constant, Rydberg constant, Stephan constant. All these constant value have the dimension. Okay, these constants are called dimensional constant. Now we are going to see the universal gravitational constant. So that value is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. This is the unit for universal gravitational constant G. Okay, already you know that, you studied this one. So G is equal to force into distance square divided by mass square. So force, you know that formula, distance also you know the formula, and mass also you know the formula. Substituting all these values, you can calculate the dimension for universal gravitational constant. So ml t power minus 2 into L square divided by m square, you will get m inverse L cube t power minus 2 is the dimensional formula for universal gravitational constant. So m cancel each other. So m square is there. மேல போச்சு அப்படின்னா m power minus 1. So L square into L cube, t power minus 2 already is in the formula. So this is a method of finding the dimensional formula for this type of constant values. Okay, so using the dimensional formula, we can calculate the dimension for all these physical quantities. So force already calculated, pressure calculated, density calculated. So these are all the values which we have calculated now. So these are all the dimensional formula for these derived quantities. And other things that quantities we can verify by using the dimensional analysis, and it has a certain limits. So now you are going to see that how to measure and how to add that length with the length. So length added to the length. So how to add that length? So length into length, you can add that it's not equal to 2 times of length. So length to length, you should not write 2 length. It's a length. That's all. So length plus length, it is a length. So you are adding the 2 length means finally you will get only 1 length. So in dimension formula, you should not write L plus L equal to 2L. It is an L. So velocity is subtracted from velocity, it will get velocity only. So velocity minus velocity, final result also is velocity. So L t power minus 1 minus L t power minus 1, you should not write 0. Okay, it is also velocity. It has the same formula, L t power minus 1. You should not write 0. Right. So these are all the some dimensional formula for the physical quantities for pressure, momentum, surface tension, electric charge, and electrical resistance. Okay, another thing, area, volume, frequency, work. These are all the dimensional formula for these derived quantities. So you can find out any quantities, can find the dimensional formula for any physical quantities by using that m, L, and t, mass, length, and time period. So using that, you can write all the calculations. Right? So next, these are all the quantities which you have derived. So dimension of some physical quantities. So these are all the quantities already we know that. So G is equal to m. These are all the exponent value. Then m, L, t is called base. So in dimension, this is called exponents, and these are all called the elements. So now we are going to see that the uses of dimensional analysis or the limitations of dimensional analysis. Right? So in this analysis, we can find out whether the equation is correct or not, or it is absolute or not. We can find out, and at the same time, we can derive the relation between the physical quantities. These are all the uses of dimensional analysis. We can relate the physical quantities. We can find out whether the equation is correct or not. So like that, we can do the calculation. So length added to the length, if you know that length plus length, you will get only length. It is not equal to 2 times of length. So you should write like this, L plus L, you will get L. You should not write 2L, right? So the next thing, we are going to see that we are added with the 2 lengths. Like that, we are adding that length, mass, time, whatever it is, we should not write that into 2 times. So now you can consider that a car is moving with a velocity v. So initial velocity is u, final velocity is v, uniform acceleration equal to a. So the displacement is s. This is the displacement, time travel time, it is t. So you know the equation for the equation of motion, s equal to ut plus half at square. That is the equation to find the displacement. Yes, right. Now we are going to find out whether the equation is correct or not by using the dimensional analysis. So dimension formula, using the dimension formula, now we are going to see that whether the equation is correct or not. So distance is s, that is equal to length l. So distance length l. So s is equal to l. So ut of at square, that 1 by 2 is a constant, it does not have any dimension. Remaining values has the dimension. So first term ut is there, u is the initial velocity, t is the time period. Okay, in that first term, so you can take the first term ut. So u is the initial velocity, t is the time period. Second term at square, where a is the acceleration, t is the time period. That 1 by 2 is not a 1 by 2 is a constant, so it does not have any dimension. So first you write that initial velocity into time ut. So dimensional formula for that, u equal to l by t, time period t equal to t. So you are substituting that value, finally you will get l t inverse t. T inverse t will become 0. So you will get finally only l. So ut equal to l. Then now we are going to see the second term of at square. Half is constant, so we can leave that constant value. Remaining you can take at square. A is the acceleration into time square, at square. Acceleration, we know the formula, l t power minus 2, and time period t square. T square and inverse square, they get cancelled 0. So acceleration a into t square, you will get final value l. So substituting all the values, see that. So what will happen? Finally, you will get the displacement s is r l, that is u equal to ut plus half at square is also l plus l. So the right side of the equation is equal to the left side of the equation. That means l. So right side s is equal to l, this side l plus l, that is also equal to l. So right side and left side of the dimension is equal. So this equation is correct. So using the dimensional formula, we can find out that equation is correct. So like that we can find out whether the equation is correct or not. Okay. So this is a method of analyze the equations. So this is one use of the dimensional analysis, right? So L equal to L, that equation is correct. There that can be explained only the equation is correct, but it's not absolute. Suppose 1 by 4 is there, that is a constant. We will leave it there. So it's not it's not say that it's absolute. It's only correct. That's all. Some physical quantities: force, pressure, volume, density, g. So this is the formula for finding these values. Already we know.